Hi, my name's Mark Lewis with Dart Controls. We're here today in the Dart R&D Center to talk to you about connecting your 253G control to a motor. Okay, so what we have here are three very popular models from the 253G series. We have the open chassis model, we have the standard on-off model, and we have a forward and reversing model. What we want to do is talk about how to connect your motor to each one of these. The chassis model is really the easiest. This is a barrier terminal strip. There are clamps here so that you don't have to have any special wiring terminations on your leads. And then the terminals are marked right on the printed circuit board. And if you'll notice right here, I have two sets of AC terminals. Two of these are for the chassis model, and the other two are for the enclosed models. So since we have the chassis model, our connections for the motor are going to be armature plus and minus. We'll talk about field in a minute. And then the AC power coming in goes on the chassis AC terminals. The only time you ever make a connection to the field terminal on any of these models is if you have a shunt or a field wound motor. It's somewhat unusual these days, but you can tell by looking at just either reading the nameplate on your motor or looking at how many leads you have. This is a DC permanent magnet motor. It has two leads. Usually black and white are your plus and minus armature, and then a green lead is your ground wire. If we had two more leads, that would tell us we have a shunt wound motor, and those field leads would go to the plus and minus field connections. A shunt wound or field wound motor doesn't have a permanent magnet in it. It has another winding that needs power from the control to create its magnetic field. So for the chassis, it's really easy. AC goes here. Motor leads go plus and minus armature. So this is the enclosed model. Let's look inside here. The unit comes pre-wired for the speed pot and the on-off switch. This is where things change a little bit. Inside is very similar to the chassis model. In fact, it's exactly the same. We're going to connect our motor to plus and minus armature. Generally, unless we have a shunt wound motor, we don't connect anything to the field terminals. But since this is an enclosed model, we're actually going to bring our AC power into the enclosed AC terminals. The last model is the reversing model. This is even a little more interesting. Again, the speed pot and the switch are pre-wired to the terminal strip. The same terminal strip we had before, except we've added a new two-position terminal strip. This is where your armature leads go on these two terminals. Even though there's already another wire there, you need to connect your motor to these two terminals. And like before with the enclosed model, your AC power goes here and here. It's labeled enclosed, AC. That's where your two AC leads go. So let's review a minute. For the chassis model, the motor connects to plus and minus armature, and the AC comes into the far right-hand two AC terminals. For the enclosed model, everything's the same except we bring it into two different terminals marked enclosed AC. For the reversing model, we bring the AC into the enclosed AC terminals, and we bring the motor leads into this two-position terminal strip. So a DC permanent magnet motor has two leads plus a ground lead. If your motor has four leads, or four leads and a ground lead, that's the only time when you're going to use the two field terminals. The reason we wanted to make this video was to help you out. We get a lot of controls that come back where the armature has been connected to the field terminals and it will damage the drive.